Hello and welcome. Today, we delve into a story that defies every expectation about what human industry can achieve, an impossible feat of shipbuilding that transformed wartime logistics and shattered centuries-old norms. Imagine a colossal cargo ship, 441 feet long and weighing 28,490,000 pounds, assembled in just 4 days, 15 hours, and 29 minutes. Without seasoned shipbuilders, but with a workforce of former secretaries, farmers, and housewives trained in weeks. How did ordinary workers, armed with welding and assembly line techniques borrowed from car factories, revolutionize an industry believed to require years? Could eliminating traditional riveting and replacing it with electric welding truly speed up ship production by hundreds of days? And what does it say about the limits of American manufacturing that, within a single year, a shipyard in Richmond could turn a muddy patch into a factory capable of launching a ship every 70 days, faster than enemy submarines could sink them? All these astonishing facts lead us to one central question. How did a nation driven by necessity and innovation reimagine the very limits of shipbuilding, creating a manufacturing miracle that changed history? I promise you, in this video, we will trace the entire journey, from the revolutionary ideas of a construction outsider to the global impact of mass-produced ships, and expose how this industrial upheaval was not just about steel and engines, but about redefining what humans can accomplish when tradition is challenged and boldness takes charge. So, prepare to see the extraordinary unfold, because the most remarkable part of this story begins right now. On the crisp autumn day of November the 12th, in the year 1942, the setting was Richmond, California, a city that was soon to become part of a revolutionary chapter in American industrial history. There, at the sprawling shipyard operated by Permanente Metals Corporation, a remarkable vessel, a cargo ship measuring exactly 441 feet from bow to stern and weighing in at an astonishing 28,490,000 pounds, was standing ready to plunge into the waters of San Francisco Bay. This colossal ship was poised at the gates of the yard, ready to venture forth, and just the day before, it had been fully assembled, an achievement that itself defied the norms of traditional shipbuilding. In ordinary circumstances, building a vessel of comparable size and complexity usually took the expert craftsmanship of seasoned shipwrights, a process that could stretch across a period of 6 to 8 months, entirely normal since the days before the American Revolution. However, here was a different story. This particular ship, known officially as the SS Robert E. Peary, had been constructed in an astonishing span of just 4 days, 15 hours, and 29 minutes. A feat that catapulted the norms of shipbuilding into uncharted territory. This unprecedented accomplishment was made possible not by veteran mariners and seasoned shipbuilders but by a diverse group of workers who had only recently learned how to weld and assemble ships. These workers came from vastly different backgrounds: former secretaries, farmers, housewives, and laborers, who had been quickly trained in welding techniques mere weeks before. They had gathered around the hull of the vessel, not as experts but as part of a broader industrial movement, and their collective effort was witnessed closely by a crowd comprising government officials, journalists, and competing shipyard owners. This event wasn't merely about constructing a ship. It marked the beginning of a systemic transformation in American manufacturing methods, a revolution in industrial production that would resonate deeply across decades to come. This was the dawn of a systematic, technological upheaval, a new wave of innovation that would redefine how the United States approached manufacturing, forging pathways that would challenge and ultimately dismantle previous assumptions about shipbuilding limitations, project timelines, and industrial capacities. The strategic calculations for Allied victories in the war wouldn't be solely determined by battlefield tactics but by groundbreaking production statistics that shattered old paradigms and demonstrated that rapid, large-scale ship manufacturing was possible at an unprecedented scale. The true catalyst for this transformation had been set into motion on December 27 in the year 1940. When Henry J. Kaiser signed his initial contract for shipbuilding. Kaiser was a man who, up until that moment, had no experience building ships or managing a shipyard, his career spanning the construction of dams and bridges across the American West, large-scale civil engineering projects that required moving mountains of earth and pouring vast quantities of concrete. At the age of 58, this construction magnate stood poised to challenge established maritime conventions. He committed himself to fabricating 30 cargo vessels for the British government within a mere 2 years, a bold promise that amazed and confounded traditional shipbuilders. Those with experience in maritime construction dismissed Kaiser as an overly optimistic, perhaps naive, opportunist who lacked the necessary expertise. One of America's most venerable shipbuilding institutions, the Todd Bath Iron Works, had reluctantly agreed to partner with Kaiser on this ambitious project, believing that their extensive experience could compensate for what they perceived as Kaiser's ignorance of ship construction. But what none of the established experts understood was that Kaiser's glaring absence of conventional shipbuilding experience would, in fact, become his greatest strength. A vital advantage that would enable him to rethink and revolutionize the entire process. Among the crowd of onlookers was William Francis Gibbs, a widely respected naval architect whose firm, Gibbs & Cox, had designed the original plans for the Liberty ships based heavily on innovations imported from British designs. Gibbs had designed more ships than Kaiser likely had seen in his lifetime. From skeptics in the beginning, the process of transformation slowly shifted, paving the way for a new industrial era, as the planning offices of Todd Shipyards in New York became the birthplace of this seismic shift. As Kaiser and his team of engineers began scrutinizing traditional methods of ship construction in early 1941, they realized almost immediately that the conventional, time-consuming methods were ill-suited for the urgent demands of wartime. The old ways, rooted in craftsmanship and meticulous assembly, could not hope to meet the overwhelming need for rapid deployment of ships across oceans and battlefronts. Kaiser's chief engineer, Clay Bedford, had recently returned from Detroit, where he had visited an automobile assembly line operated by the Ford Motor Company. Having observed the smooth, efficient movement of automobile chassis down a conveyor belt, with components being installed swiftly at each station by workers trained for specific tasks, Bedford was struck by the possibilities of applying similar principles to shipbuilding. He was convinced that ships could be manufactured in the same way, constructed rapidly and systematically, in an assembly line fashion. However, this revolutionary idea was met with skepticism. The first truly groundbreaking revelation came when Kaiser suggested eliminating the traditional riveting process altogether. For centuries, shipbuilding relied heavily on riveting, a labor-intensive technique where heated metal pins, known as rivets, were hammered through overlapping steel plates to secure the hull together. This method demanded not only considerable skill but also a highly coordinated workforce capable of installing rivets meticulously. On average, a talented and well-coordinated riveting crew could manage to install around 100 rivets in a single day. Considering the enormous scale of what was needed, a typical Liberty ship, constructed under the conventional process, would require approximately 1 million rivets to complete. Kaiser, however, proposed a radical departure from this tradition, to replace riveting with electric arc welding, a technique he had gained extensive experience with while building pipelines across the expansive American West. His familiarity with welding technique, honed through numerous pipeline projects, convinced him that this modern method could significantly speed up ship production. Nevertheless, this idea met with fierce skepticism from the maritime establishment. Vice Admiral Emory Land, who served as the chairman of the United States Maritime Commission, scrutinized Kaiser's proposal with a cautious and doubtful eye. His private correspondence, now preserved within the National Archives, vividly captures the initial doubt and concern shared by many in the naval and maritime circles. To them, welding had never proven its reliability at the massive scale required for ship hulls. In fact, the British Navy, highly experienced with vessel construction, explicitly forbade welding on the hulls of warships, citing concerns over the durability and integrity of welded joints in such critical structures. Kaiser's suggestion was perceived as an audacious gamble, an attempt to entrust the security of America's vital supply lines to a technology that had seen little real-world application at the size and scale needed. This was especially troubling given the context of the raging Second World War, where the safety of supply routes was paramount. Land also understood the urgency born of desperation. German U-boat and surface raider attacks were sinking Allied merchant ships at an alarming pace, with the loss of approximately 3,600,000 tons of Allied shipping just in the year 1941. These losses threatened to choke the vital flow of supplies across the Atlantic. The situation was desperate enough that Britain's blockade of supplies was causing severe shortages. The country was effectively starving due to its inability to replace ships fast enough. On the American side, traditional shipyards employing conventional construction methods would take around 230 days, roughly 7.5 months, to complete a single cargo ship. At that rate, the Allies' ability to sustain the fight in the Atlantic was at risk of collapsing before American industry could ramp up production to meet wartime demands. Given this dire urgency, the decision to move forward with Kaiser's revolutionary contract was less an expression of confidence and more a necessity born of wartime exigency. The Richmond shipyard, which had previously been nothing more than a stretch of vacant mud flats, was transformed within the span of less than a year, from January to December of 1941, into a hub of rapid ship production. Kaiser's innovative approach to construction was revolutionary not only in technique but also in design philosophy. Unlike traditional shipyards, which relied on massive gantry cranes and lengthy building ways arranged linearly, the Richmond facility resembled an automobile assembly plant, a stark contrast to the artful, labor-intensive methods of the past. The yard was laid out with numerous open spaces designated for prefabrication, where large ship sections could be assembled off-site before being brought together. These sections, some weighing as much as 150 tons, were transported along covered railroad tracks crisscrossing the entire yard, designed explicitly to allow for swift movement of the enormous steel components. Overhead cranes, capable of lifting entire sections of the ship, were positioned at intervals every 100 feet, ready to efficiently place massive pieces without delay. This was a radical shift from the old system of on-site assembly and heavy manual labor, aiming instead for rapid, modular construction. In May of 1941, John Riley, chief naval architect at Bethlehem Steel Corporation and a seasoned expert with over 30 years of experience in shipbuilding, visited the Richmond yard. His confidential inspection report, a document rich with technical insights and candid criticism, revealed a mixture of shock and grudging admiration. Riley noted that Kaiser's design had upended every principle of efficient shipyard layout he had learned over 3 decades. The prefabrication zones were excessively large, and the crane capacities appeared overly powerful for what was necessary. The building ways, too, were shorter than traditional designs mandated. Despite these criticisms, Riley acknowledged that the entire facility was intentionally designed for the specific goal Kaiser envisioned: the rapid assembly of prefabricated sections into complete ships, an approach that, despite its radical departure from norm, matched the ambitious speed objectives. The next crucial phase in this revolutionary process was the assembly of a workforce capable of executing the unorthodox construction techniques. Traditional shipyards drew their workers from established maritime communities, regions. The transfer of skills from father to son has been a fundamental aspect of human tradition, passing down knowledge, craftsmanship, and expertise through countless generations. In the early days of wartime shipbuilding, Henry Kaiser took this age-old concept and applied it in a revolutionary manner to meet the urgent demands of the war effort. He launched aggressive advertising campaigns across newspapers throughout the United States, enticing individuals with promises of wages that exceeded the standard industrial rates by 20%. Alongside the tempting pay, he offered comprehensive training programs designed for anyone willing to commit to work, regardless of their previous experience or background. In August of 1941, the first groups of eager workers arrived in Richmond, eager to participate in this new approach to shipbuilding. The traditional methods of training skilled welders, which typically involved 4 years of apprenticeships to acquire a broad, deep knowledge of various techniques, were replaced by a streamlined, targeted training regimen. Kaiser's instructors focused on teaching specific tasks, such as welding particular types of seams on different parts of the ship, over a span of approximately 2 weeks. Unlike traditional shipbuilders who required extensive experience and skill to manage every aspect of construction, Kaiser's method only called for workers to master their designated task repeatedly, such as welding vertical seams on bulkheads or horizontal deck plates or curved hull sections, instead of learning to build everything from scratch. This radical simplification of complex processes into a series of repetitive, specialized tasks, borrowed directly from assembly line manufacturing, proved to be devastatingly effective. As workers gained hands-on experience during late 1941 and into 1942, an astonishing trend emerged. The construction time for Liberty ships, which had initially been around 197 days for the very first vessel built in Richmond, began to plummet. The second Liberty ship was completed in just under 169 days. By the time the fifth ship was finished, the construction time had been reduced further to approximately 128 days. The 10th vessel was completed in an astonishing 97 days. By spring of 1942, the shipyard in Richmond was routinely completing Liberty ships in an average of merely 70 days. This rapid increase in productivity drew the attention and growing concern of traditional shipyards, which watched in alarm as Kaiser's untrained workforce matched, and in some cases even surpassed, the output of their highly skilled crews. The key to Kaiser's success lay in his pioneering prefabrication approach, which drastically differed from conventional methods. Instead of constructing ships sequentially, starting from the keel and progressing upward to the deck, Kaiser's yards fabricated entire sections simultaneously across different parts of the facility. While one team assembled the bow section in the prefabrication area, other teams were concurrently building the stern section, deckhouses, engine rooms, and bulkheads in separate locations. Once these sections reached completion, massive cranes lifted them into position on the building ways, where welding crews seamlessly joined the components together into a cohesive whole. Albert Wooding, a production supervisor at Richmond Yard No. 2, vividly described the efficiency of this process during an interview with Fortune magazine in 1943. He explained that in traditional shipbuilding, The operations follow a strict sequence. The engine cannot be installed until the engine room is built, and the engine room cannot be built until the hull is complete. Everything proceeds step by step, which naturally lengthens the entire process. In stark contrast, Kaiser's method facilitated parallel production, allowing different parts of the ship to be built simultaneously. While one team welded hull plates in one area, another team assembled the engine in a separate workshop. When both components were ready, they were combined swiftly. The engine was precisely dropped into the prefabricated engine room and welded into place, dramatically reducing the time required for tasks that traditionally took weeks. This approach unveiled manufacturing efficiencies that seemed impossible within the framework of traditional shipbuilding. For example, whereas a conventional shipyard might have required around 50 workers working in cramped, partially completed engine rooms over a span of 3 weeks to install an engine, Kaiser's team, comprising approximately 200 workers, could complete the entire engine assembly and its mounting structure in just 5 days in an open workshop. Large cranes then lifted the completed engine into the ship, where further welding finalized the installation. Tasks that previously demanded extensive labor and extended timelines were accomplished in mere hours, exemplifying a level of productivity that defied traditional expectations. The statistics supported this claim. The prefabricated engineering components, such as engines, were assembled in a fraction of the time it used to take by conventional means, illustrating the immense efficiency gained through this groundbreaking, parallel process methodology. Imagine the bold ambition of orchestrating an entire ship assembly within a single 8-hour span, a feat that seemed almost impossible just a few years prior. This audacious goal highlighted a shifting attitude within the maritime industry, one that was increasingly receptive to unconventional methods, even if they clashed with long-standing traditions. To the maritime authorities rooted in history, the idea of abandoning centuries-old shipbuilding techniques was nothing short of shocking. Traditionally, ships had been constructed according to meticulously detailed plans, with every line and measurement carefully drafted to ensure precision and safety. These plans served as the blueprint for every vessel, leaving little room for deviation. However, a new approach, championed by a figure named Kaiser, proposed a significant departure from this meticulous tradition. Instead of detailed blueprints, Kaiser utilized streamlined drawings that only specified the essential dimensions. From there, he entrusted the specifics of assembly and finishing to the judgment of skilled workers, believing that flexibility could lead to faster production. This approach, regarded as reckless by seasoned builders accustomed to precision, Kaiser's defenders called it a necessary adaptation, an acceptance of flexibility in the face of the urgent wartime demand for rapid ship production. Initially, this departure from tradition met resistance from influential figures such as Vice Admiral Howard Vickery, who served as vice chairman of the Maritime Commission and possessed a lifetime of naval experience. Vickery strongly opposed Kaiser's simplified specifications, fearing that sacrificing accuracy could jeopardize safety and quality. Yet, as time progressed and the results of Kaiser's methods became apparent, his stance evolved. Documented in meeting minutes of the Maritime Commission, Vickery's change from a skeptic to an advocate underscored how tangible outcomes could outweigh theoretical concerns. This transformation reflected a broader shift. Even staunch defenders of traditional standards gradually recognized that in wartime, success often depended on achieving results quickly, even if that meant accepting a certain level of imperfection. Back in January of the same year, I personally opposed Kaiser's proposal to further reduce drawing specifications, emphasizing the importance of precision in shipbuilding. After all, Ships are complex vessels where accuracy is not merely desirable but essential. Unlike automobiles, which can often tolerate a degree of variation, maritime construction demands strict adherence to specifications to ensure safety and durability. Nonetheless, despite these reservations, by March, Kaiser's shipyards had impressively outpaced traditional competitors by building 40% more vessels in the same timeframe. This remarkable increase in productivity demonstrated that speed could be achieved without compromising the fundamental purpose of the ships. As the months went on, and by June, the productivity gap had widened to a staggering 70% advantage for Kaiser's yards. It became clear that the notion of perfection as an absolute was, in this context, a hindrance rather than a help. I came to understand a vital lesson. Striving for flawlessness can actually hinder progress when timely delivery is critical. Kaiser's ships, while not beautiful or crafted with exquisite detail, proved to be sufficiently functional. They were adequate, in the best sense of the word. These ships might not have been masterpieces of design, but they delivered more cargo, more quickly, than the meticulously detailed vessels that were still under construction elsewhere. It was a pragmatic realization that in wartime, practicality and speed often trumped traditional notions of beauty and perfection. Throughout the spring and summer of 1942, as the pace of construction accelerated even further, a spirited rivalry emerged among Kaiser's 7 shipyards. These facilities, spread across California, Oregon, and Washington, became the battlegrounds of a friendly but fierce contest. Edgar Kaiser, serving as vice president and general manager, was directly involved in overseeing operations, especially at the Oregon Shipbuilding Corporation in Portland. Clay Bedford, responsible for the Richmond yards in California, was equally ambitious. Driven by a shared desire to excel, the two men began an informal competition. Whose yard could expedite shipbuilding more rapidly? This contest quickly captured public attention, turning the yards into a spectacle akin to sports tournaments. Newspapers began reporting weekly scores, comparing the number of ships completed, with updates published with the enthusiasm and regularity of sporting events. Records were shattered one after another as yards pushed their limits. For example, in September of 1942, Oregon's shipyard managed to construct the Liberty ship Joseph N. Teal in just 10 days, an astonishing feat that broke previous speed records and drew awe from industry observers. Such remarkable accomplishments did not go unnoticed. Vice Admiral Vickery, initially skeptical of the racers' methods, eventually intervened, calling an end to the speed competitions. He deemed them distractions that detracted from the core goal of steady, reliable production. Despite the formal stoppage, the underlying messages had already resonated deeply. Workers at all the yards had internalized a vital truth. Building ships at extraordinary speeds was not only possible but was now a standard expectation, ingrained in the industry's culture. Then, in November of 1942, the ultimate demonstration of this newfound capability arrived. During a visit to the Richmond yard, Vice Admiral Land happened to make an offer on the condition that it does not interfere with the established schedules of our regular production flow. Significant strides were made in the construction process. The decision was made to select the 47th hull for the record-breaking attempt, choosing Yard Number 2 as the site for this ambitious project. This particular vessel was to be christened the SS Robert E. Peary, named in honor of the renowned Arctic explorer whose legacy symbolizes determination and endurance in the face of icy adversity. Beginning on Sunday, November the 8th, at exactly 1 minute past midnight, a concerted effort involving over 1,000 skilled workers commenced. These workers, arranged in meticulously coordinated shifts, aimed to achieve what had never been accomplished before in the annals of maritime construction. Their coordinated efforts marked a convergence of innovation, precision, and speed, setting the stage for a historic achievement. The prefabrication approach reached its pinnacle during the phase of pier construction, exemplifying unprecedented levels of planning and execution. Every major component necessary for the vessel's completion had been meticulously built, thoroughly inspected, and staged at strategic points before the keel was even laid upon the building ways. This careful preparation ensured a seamless assembly process. For example, the bow section, which comprised upwards of 50 individual steel pieces, was entirely welded and fitted with anchor hardware, chain lockers, and forward crew quarters before the assembly commenced, demonstrating a remarkable degree of advance readiness. Similarly, the stern section featured a fully assembled steering gear system, a propeller shaft, and the quarters designated for the aft crew. 4 comprehensive cargo holds, each a sizable rectangular steel structure engineered for maximum capacity, had been pre-built and weighted meticulously to facilitate their handling and precise placement. The main propulsion engine, a colossal triple-expansion steam power plant weighing approximately 140 tons, was constructed by Joshua Hendy Iron Works in Sunnyvale. This vital component had been mounted onto its foundation and subjected to rigorous testing at the factory prior to its inevitable installation. Contrasting sharply with what traditional shipyards would take months to accomplish, from initial keel laying to final deck fitting, Kaiser's yards orchestrated the assembly of an almost complete ship within mere days. Their process involved prefabricated sections being brought together rapidly, eliminating the drawn-out construction timelines typical of conventional practices. By the 4th day of work, the hull had been fully assembled, with the engine installed, deck houses positioned, cargo holds securely in place, and steering gear mounted, all within just 4 days. On Thursday, the 12th of November, at precisely 3:30 in the afternoon, just 4 days, 15 hours, and 29 minutes after the keel had first touched the building way, the SS Robert E. Perry was moved swiftly down the launching rails into the shimmering waters of San Francisco Bay. This event marked the culmination of their extraordinary efforts. The ship was officially delivered for active service by November the 15th, completing a remarkable timeline of 7 days, 14 hours, and 32 minutes from the laying of the keel to the vessel's full readiness. The launch drew a sizable crowd of bemused yet intrigued observers, including maritime officials, military representatives, competing shipyard owners, and journalists from across the United States. Many among these onlookers had arrived skeptical, expecting the vessel either to fail altogether or to appear superficially complete without the necessary functionality. However, what they witnessed defied all expectations. A fully operational ship that only required minor fitting adjustments before it could commence service. From its steel frames to its powerful steam engine, everything was in place and ready for duty. During the event, Vice Admiral Land, present for the launch, briefly addressed the gathered crowd, his remarks captured by newsreel cameras. His speech succinctly summarized the profound shift occurring within the maritime industry. He stated that only 6 months prior, he would have deemed such a rapid construction impossible. He acknowledged that traditional shipbuilding, an industry built on centuries of cumulative experience, held the belief that constructing a proper vessel would require many months, often several years. Yet, thanks to the innovations introduced by Henry Kaiser and his team, that long-standing wisdom was now rendered obsolete. The Vice Admiral emphasized that Henry Kaiser had effectively revolutionized shipbuilding, making it feasible to construct ships in record time, turning what was once thought impossible into reality. He announced that the United States Maritime Commission, recognizing the immense potential of these new methods, would now mandate that all their contracted shipyards adopt Kaiser's innovative approaches. This revelation sent shockwaves through the shipbuilding community, affecting deeply rooted mindsets. The impact on traditional shipbuilders was immediate and profound. Just 18 months earlier, the yards that now studied Kaiser's methods had dismissed him as an inexperienced outsider, unworthy of serious attention. Now, in light of his extraordinary feat, those same yards sent their engineers to observe and learn from his process, eager to understand the secrets behind his rapid success. The president of the historic New York Shipbuilding Corporation, one of the oldest and most prestigious naval construction firms in America, took the step of visiting Kaiser's yard, an unprecedented move that in December of 1942, the city of Richmond became a focal point of unprecedented industrial activity, driven by a revolutionary approach that challenged every pre-existing notion of traditional shipbuilding. At the forefront of this transformation was a figure whose confidential report to the company's board of directors laid bare a fundamental shift in ideology. The old, time-honored methods founded upon craftsmanship and centuries-old procedures had utterly collapsed under the weight of modern necessity. This visionary, known for his relentless innovation, had achieved what the entire maritime industry once considered impossible. He had refused to accept the limitations that had long been deemed inherent to ship construction, instead reimagining the process as a purely manufacturing problem to be solved through engineering that was streamlined and optimized for speed and efficiency. This approach marked a stark departure from conventional practices. The traditional craft traditions that had once defined shipbuilding, emphasizing meticulous handwork and bespoke craftsmanship, were cast aside. Instead, the new paradigm focused on simplification rather than perfection, standardization rather than customization. Skilled artisans, who once took years to master their craft through generations of training, were replaced by masses of unskilled or semi-skilled workers who could be trained rapidly. Kaiser's methods drastically shortened construction timelines and cut costs. Ships could now be built in 1/10 the time previously required, at just 2/3 of the former cost. This revolutionary change not only challenged but threatened to obsolete the old standards and practices, forcing the industry to confront a stark reality. To remain relevant, it must either adapt to Kaiser's innovative methods or face irrelevance. By the early months of 1943, Kaiser's influence had become a transformative force across American maritime production. His revolutionary ideas had permeated 18 shipyards scattered across the country, where a new method of prefabrication combined with welding technology was employed extensively to mass-produce Liberty ships. The traditional average construction time, about 230 days, had been reduced dramatically by this point, shrinking to just 42 days by the middle of 1943. Such acceleration meant that the United States was setting a new standard. It was now launching 3 Liberty ships every single day, a tonnage capacity that surpassed what German submarines could sink in the Atlantic. This relentless pace became a critical strategic advantage, bolstering Allied logistics at an unprecedented scale. Yet, perhaps the most disruptive challenge that Kaiser's approach posed to the established maritime hierarchy was not merely in speed or cost but in the workforce itself. The ship's builders, mostly newly recruited women, minorities, and untrained laborers, represented a sharp departure from the traditional guild system, that centuries-old hierarchy of master craftsmen and apprentices, that had long controlled shipbuilding. These unseasoned workers, who assembled vessels with remarkable speed and competence, embodied a democratization of industrial labor. At the peak of production in 1944, Kaiser's 7 shipyards employed approximately 196,000 workers, among whom over 40,000 were women, an impressive share of female participation in industrial employment for that era. By mid-1944, women constituted about 27% of the workforce at Richmond alone. The 3 Kaiser yards in the Northwest region employed over 31,000 women by 1944, illustrating the profound shift in workforce demographics. Equally significant was Kaiser's employment of African American workers, tens of thousands of them, who occupied skilled positions traditionally reserved for more experienced craftsmen. These roles included welding, fitting, crane operation, and even supervision, a level of workplace integration that was highly unusual for the social norms of 1940s America. Such integration not only advanced the war effort but also carried far-reaching implications beyond the immediate needs of production. Kaiser's model proved conclusively that complex manufacturing processes could be successfully executed by a diverse and relatively untrained workforce, provided they received proper training. This challenged deeply ingrained notions that high-skilled, generational craftsmanship was indispensable, opening the door for broader social and industrial changes. During the Christmas of 1943, this transformed industrial culture became even more evident. While traditional shipyards observed the holiday with brief breaks, 1 or 2 days away from work, Kaiser's yards maintained their relentless production schedules. Yet, rather than simply insisting on continuous work, Kaiser's organization fostered a culture of recognition and appreciation. Workers received Christmas dinners served on-site in plant cafeterias, featuring turkey, ham, and all the traditional accompaniments, offered at no cost to those working. During the holiday period, local churches sent carolers to lift spirits, and the Richmond Municipal Band performed seasonal music, creating festive, community-centered celebrations within the industrial environment. Kaiser himself made personal visits to the yards, shaking hands with workers and expressing heartfelt gratitude for their dedication and service. By the middle of 1944, Kaiser's 7 shipyards had collectively produced over 800 Liberty ships, a feat that underlined the extraordinary accomplishments of this industrial revolution. In essence, the shift initiated by Kaiser and his innovative methods not only transformed the physical landscape of American shipbuilding but also ignited a profound social transformation, one that redefined notions. The impact of Kaiser's innovative shipbuilding methods extended well beyond his immediate facilities, exerting influence across the entire maritime industry of the United States. During the peak period of World War II, a collective of 18 American shipyards was engaged in constructing Liberty ships, which by this point in time had collectively produced a staggering total of 2,400 vessels. These ships were revolutionary in their design and construction techniques, serving as the backbone of America's wartime logistics. Following the introduction of their successor, the Victory ships, which featured a larger size and faster speed to amplify the efforts begun with Liberty ships from the year of 1944 onward, the same prefabrication and welding techniques that Kaiser had pioneered were seamlessly adopted, further accelerating production and efficiency. In total, American maritime manufacturing between the years of 1941 and 1945 exceeded 5,500 vessels, amassing approximately 53 million tons of shipping capacity. To contemporary observers, these figures represented an industrial feat of unprecedented scale. While such rapid and expansive production might seem ordinary today, at the time it was nothing short of extraordinary, capturing the imagination and awe of many. An illustrative example was Commander Joseph Kenworthy of the Royal Navy, who was assigned to the British delegation led by Admiral T in Washington. He observed American shipbuilding efforts with a mixture of admiration for their productivity and admiration mingled with envy. His official reports, which were declassified during the 1980s, provided a valuable insight into the British perspective on American industrial prowess. These documents highlighted how deeply impressed they were by the capacity of the United States to manufacture ships at a rate far exceeding that of other nations. Indeed, the United States was building merchant ships at a pace that outstripped the combined output of the rest of the world. At the time, Kaiser's shipyards alone were producing more tonnage each month than the entire British shipbuilding industry. Although their ships might have been considered somewhat crude in design and appearance by traditional standards, their practicality and functionality were undeniable. They successfully floated, carried cargo, and supported the enormous logistical demands of war. In comparison, Britain had long been renowned for constructing some of the finest warships in the world, renowned for their elegance and craftsmanship, often taking years to complete each vessel. Conversely, the Americans focused on producing ships that, while perhaps less refined in appearance, were sufficient and reliable in function. These ships were built within weeks, and the multiplication of these adequate vessels, thousands in number, proved more effective than the pursuit of perfection in a smaller fleet. Perhaps the most astonishing aspect of Kaiser's transformation of shipbuilding came in the aftermath of the war's conclusion. Prior to the conflict, traditional analysts anticipated that the wartime shipbuilding boom would abruptly cease, leaving tens of thousands of workers unemployed and rendering hundreds of costly shipyards obsolete. This prediction, while partially accurate, did not tell the full story. Liberty ship production officially ended in September of 1945. By the following December, Kaiser's once flourishing workforce had diminished from a peak of 200,000 workers down to fewer than 20,000. Similarly, the Richmond shipyards, which had employed 100,000 people at their height, stood largely abandoned by the spring of 1946. Yet, despite the dramatic decline in immediate wartime activity, the technical expertise and manufacturing practices developed during this emergency period persisted and left a lasting legacy. The innovative prefabrication techniques, welding procedures, and methods of parallel assembly established by Kaiser did not vanish with the end of wartime production. Instead, they became standard practices adopted worldwide. When Japan and South Korea sought to rebuild their maritime industries during the 1950s and 60s, they turned to the experience gained from Kaiser's Liberty ship program, integrating his approaches into their own shipbuilding methods and establishing the foundations of their modern shipyards. Today, the sprawling shipbuilding facilities in Ulan, South Korea, and Nagasaki, Japan, such as those that would dominate global maritime construction for decades, are direct descendants of the revolutionary practices pioneered at Richmond. The influence of Kaiser's innovations profoundly shaped the development of shipbuilding technology in the post-war era. Maritime historian John Bunker, a professor at the State University of New York Maritime College, summarized Kaiser's enduring legacy in his comprehensive study published in 1972. He observed that Kaiser entered the industry as an outsider, uninformed about traditional maritime practices and unbound by conventional wisdom. Instead, he was willing to apply manufacturing principles borrowed from other industries, principles that enabled a leap forward in efficiency and output, ringing in a new era of ship construction that prioritized speed, affordability, and mass production over meticulous craftsmanship. The shipbuilding industry was traditionally regarded as an area ill-suited for rapid, large-scale production, often seen as complex, labor-intensive, and requiring considerable skill and craftsmanship. However, in an extraordinary achievement, a single visionary figure managed to defy these conventions. Over the span of just 3 years, 36 months, This individual oversaw the construction of more ships than the entire United States had managed to produce over the course of the preceding 100 years combined. This remarkable feat not only shattered previous notions about the capacity and speed of shipbuilding but also set in motion a profound transformation that would influence maritime construction practices worldwide for the remainder of the 20th century. More significantly still, the influence of this pioneering effort extended beyond mere numbers. The methods and technological innovations introduced under his leadership fundamentally changed the way ships were designed, built, and assembled across the globe. Among his groundbreaking contributions were the development of modular construction techniques, the extensive use of prefabrication, where large sections of ships were built separately and then assembled together, and the widespread adoption of welded assembly methods. These innovations have since become standardized practices in the modern shipbuilding industry. Today, whether one observes container ships crafted in South Korea, oil tankers constructed in Japan, or luxurious cruise ships built in Europe, all these modern vessels draw heavily from the processes first popularized by the Liberty Ship program led by Kaiser. The scale and success of Kaiser's achievements can be best appreciated when examining the statistical data that highlights both the enormous scope of the project and its extraordinary accomplishments. Between the years of 1941 and 1945, a total of 2,710 Liberty ships were built across 18 different American shipyards. At the peak of production, this equated to an astonishing average of approximately 1.8 ships constructed each day, a level of productivity previously thought impossible for such complex vessels. Kaiser's 7 shipyards alone were responsible for building around 1,490 ships, which accounted for roughly 27% of all American wartime merchant shipping produced under the auspices of the Maritime Commission. Such a concentration of effort in Kaiser's yards demonstrated the extraordinary scale of his operation. The evolution of construction times over these years underscores the rapid learning curve. Initially, the first Liberty ships took around 230 days from laying the keel to launching, but by 1943, this period had dramatically reduced to only 42 days. The record for efficiency was set by the vessel named Robert E. Perry, which required a mere 4 days and 15 hours from the start of construction to its launch, a staggering reduction in building time. This rapid improvement was largely driven by workers gaining experience, which led to dramatic increases in labor productivity. For example, the initial Liberty ships required around 1.1 million worker hours to complete, whereas by 1943, that figure had fallen to roughly 486,000 worker hours per ship. Within Kaiser's yards, some facilities achieved truly extraordinary levels of efficiency. Richmond yards number 2 and 3 attained production output with as few as 350,000 worker hours per ship, thanks to the implementation of round-the-clock production schedules, operating 3 shifts over 24 hours, and a focus on prefabrication techniques that minimized on-site assembly and labor. These advances in efficiency were mirrored by significant reductions in costs. The first Liberty ships, built at the beginning of the program, cost approximately $1.75 to $2 million each. However, by 1943, these costs had decreased to around $1.8 million, despite wage increases and rising prices of raw materials, indicating not only learning curve effects but also cumulative improvements in construction processes. In terms of capacity, each Liberty ship displaced about 14,245 tons when fully loaded, and had the cargo capacity to carry approximately 10,800 tons of freight. This meant that in a single voyage, these ships could transport an impressive array of military equipment and supplies, ranging from roughly 2,840 jeeps to about 440 tanks, or even 230 million rounds of ammunition. Powered by triple expansion steam engines, a deliberately old-fashioned but consistently reliable and easy-to-manufacture type, the ships could achieve a speed of approximately 11 knots, which was sufficient for convoy escort operations during wartime. The training of workers to operate and assemble these ships proved to be equally revolutionary in its efficiency. Kaiser's employment of specialized schools enabled workers to acquire the necessary skills in remarkably short periods, on average, about 2 weeks. In the fastest cases, newly trained spot welders, whose role was crucial in welding the ship's sections, attained full productivity in just 10 days. More complex positions, such as crane operators or ship fitters, required slightly longer training periods, often between 4 and 6 weeks. This intense focus on specialization allowed workers to master specific, repetitive tasks that they could perform hundreds of times during the construction process, contrasting sharply with the traditional maritime apprenticeship model, which typically required 4 years of training for basic competency and up to 10 years to achieve the status of master craftsman during the tumultuous years of World War II. The incredible resilience and efficiency of the Liberty ships stood as a testament to innovative engineering and rapid construction techniques. Despite initial doubts and widespread skepticism surrounding the feasibility of such quick assembly methods, these ships proved their worth time and again, demonstrating that speed did not necessarily come at the expense of durability or seaworthiness. Out of a total of 2,710 Liberty ships constructed during this period, approximately 200 were lost due to enemy action. This equates to a loss rate of roughly 7.4%, a figure that, when put into perspective, compared quite favorably with the loss rates experienced by merchant ships before the war. Such statistics clearly indicated that even with their expedited build process, welded hulls, initially thought to be questionable in terms of strength, were indeed capable of enduring the rigors of the open sea, and these vessels could be relied upon for long voyages and heavy duty. However, it's important to acknowledge that the rapid construction and welding techniques were not without their issues. Some ships encountered structural setbacks due to welding imperfections, which in some cases led to severe failures. Among these, 3 Liberty ships suffered catastrophic breaks in half due to brittle fracture phenomena. While this was a minuscule proportion, only about 0.11% of the total production, such failures drew significant attention and prompted intensive investigations. Over the course of the war, nearly 1,500 incidents of brittle fractures were documented across the Liberty fleet, with most remaining minor irreparable, and full, catastrophic breaks being exceptionally rare. These incidents served as a catalyst for substantial improvements in welding practices, the refinement of steel standards, and quality control procedures. By the year 1944, these corrective measures successfully eliminated the brittle fracture problem, reaffirming the safety and longevity of welded steel ships. The ultimate validation of Kaiser's construction methodology came through the impressive longevity of the Liberty ships themselves. Originally designed as emergency vessels with a projected service life of no more than 5 years, these ships often exceeded expectations to an extraordinary degree. Many of the vessels remained operational for decades following the conclusion of World War II. A particularly striking example is the SS John W. Brown, launched in 1942, which as of the year 2024, continues to be a functioning museum ship docked in Baltimore. This vessel's enduring presence nearly 8.5 decades after her initial commissioning highlights her remarkable durability. Similarly, the SS Jeremiah O'Brien, also built in 1942, has been preserved in San Francisco. Notably, It participated in the commemoration events marking the 50th anniversary of D-Day in 1994, and astonishingly, sailed under its own power to Normandy for the ceremonies after having survived half a century of service and neglect. A third notable Liberty ship, the SS Helles Liberty, has found a new life as a static museum in Greece, serving as a historical exhibit dedicated to the shipbuilding feats of the era. Beyond their wartime service, many Liberty ships embarked on second careers that stretched well past their original intended lifespan. Of the roughly 2,510 ships that managed to survive the war, approximately 835 remained engaged in commercial trade into the 1960s. Several of these vessels were sold to foreign shipping companies, which continued to operate them into the 1970s, extending their operational lives for decades beyond their initial purpose. The last Liberty ship built, the SS Albert MBO, delivered on October 30, 1945, was not destined for the scrap yards at the war's end. Instead, it was converted for civilian use. Sold in 1964 for $65,557, it became the fish cannery ship known as Star of Kodiak in 1965. This enduring vessel remains today, now serving as the landlocked headquarters of Trident Seafoods located in Kodiak, Alaska, an astonishing 8 decades after her initial construction. The economic ripple effects generated by the Liberty ship program extended far beyond their immediate operational utility. The immense steel demands associated with rapid ship construction drove the expansion of steel manufacturing capacity across the United States, particularly on the West Coast. To meet this critical need, Kaiser Steel established the Fontana Steel Mill in California, which was specifically built to supply the steel required by Kaiser's shipyards. Completed 5 months ahead of schedule in 1942, this facility could produce approximately 700,000 tons of steel annually, and it played a pivotal role in establishing California as a major steel-producing region for the first time in American industrial history. Alongside steel, essential materials such as magnesium used in incendiary bombs and aluminum for aircraft were produced in Kaiser plants established to support the broader war economy. The employment effects of these industrial expansion projects created a ripple through communities across California, Oregon, and Washington states. For example, the city of Richmond, California, experienced explosive growth. Its population increased from around 23,000 residents in 1940 to over 100,000 in 1943, largely fueled by the surge had been overly restrictive, and that with innovative management and a clear sense of purpose, it was possible to dramatically accelerate industrial output. This realization shattered long-held assumptions about the limits of American manufacturing, highlighting that flexibility, efficient coordination, and technological innovation could unlock untapped potential. The rapid scaling of shipbuilding under Kaiser's leadership not only bolstered the nation's wartime logistics but also stimulated a profound cultural shift within American industry. It fostered a mindset that emphasized agility, problem-solving, and strategic organization, qualities that would influence post-war industrial recovery and development. The newly acquired confidence in rapid, large-scale production proved pivotal in shaping the future of American manufacturing beyond the war effort. Furthermore, the success of the Liberty ship program underscored the importance of collaborative, cross-disciplinary teamwork. Engineers, workers, managers, and scientists worked in unison, sharing knowledge freely and overcoming technical hurdles through collective ingenuity. This culture of collaborative problem-solving laid the groundwork for later innovations across multiple sectors, reinforcing the idea that complex technological challenges could be addressed swiftly when unified efforts were employed. In addition to the tangible technological and organizational advancements, the program also played a vital role in social transformation. It empowered countless young individuals, particularly women and minorities, by providing opportunities to acquire skills, earn livelihoods, and participate in the nation's wartime production effort. Many of these workers gained skills and confidence that enabled them to pursue careers in diverse fields long after the war ended, thereby contributing to broader socio-economic progress. The shipbuilding innovations that arose during this period radiated outward, influencing industries far beyond maritime construction. Techniques such as advanced welding, developed under intense wartime pressure, became standard procedures in fields including large-scale steel structure fabrication and the manufacturing of pressure vessels used in energy and chemical industries. The methods of prefabrication, pioneered at shipyards in Richmond, laid the foundation for modern practices in building residences, bridges, and large industrial complexes. Organizational principles like parallel production lines, simplified technical specifications, and rapid workforce training evolved into core concepts that underpin contemporary operations management and industrial engineering education. These approaches enabled faster, more flexible manufacturing processes and helped streamline complex projects, setting a precedent for efficiency in various sectors. The significance of the Liberty Ship program extends into the realm of economic competitiveness. As Professor Michael Porter from Harvard Business School highlighted in a comprehensive analysis of American industrial strength in the year 1985, this initiative serves as a prime example of how rapid capability development can be achieved. Kaiser's enterprise demonstrated that national industrial capacity is not inherently limited. Rather, it can be cultivated swiftly through strategic focus, innovation, and resourcefulness. At the outset of World War II, the United States lacked a substantial merchant fleet, with limited shipbuilding infrastructure and expertise. Yet, within just 2 years, American shipyards outproduced all other nations combined, effectively transforming the country into the world's dominant maritime manufacturer. This extraordinary feat proved that, with well-organized systems and clear objectives, industries could overcome perceived constraints and achieve unprecedented growth in record time. This lesson extends well beyond wartime exigencies. It suggests that many perceived limitations, whether technological, organizational, or capacity-related, are often surmountable when driven by necessity and supported by effective leadership. The experience of the Liberty Ship program underscores that physical or resource-based constraints are frequently rooted in organizational challenges, and addressing these via innovative management and rapid learning can unlock vast potential. Equally impactful was the psychological transformation instilled among America's industrial leaders and engineers. Kaiser's approach challenged the prevailing notions of what was achievable within manufacturing. Previously, many accepted certain limits as inherent, dictated by tradition or perceived technical complexity. Kaiser demonstrated convincingly that these limits were largely mental constructs, removable through strategic thinking, dedicated effort, and a shared sense of purpose. This shift in mindset cultivated a spirit of experimentalism and resilience in American industry, fostering a culture willing to embrace bold solutions and adapt swiftly to changing circumstances. It illuminated the importance of leadership that instills confidence and encourages innovation, ultimately enabling the nation to mobilize its full industrial potential when circumstances demand it most. In sum, the Liberty Ship program was not only a masterclass in rapid industrial scale-up but also a catalyst for enduring technological, organizational, and societal change. It proved that with purposeful leadership, inventive strategies, and collective effort, even the most daunting challenges could be met and transformed into opportunities. Lessons that continue to resonate in today's pursuit of progress and resilience. Throughout history, it has often been suggested that true innovation and groundbreaking progress stem from entirely new ideas, revolutionary theories, or radical departures from established practices. However, the story of the Liberty ships vividly illustrates a different, perhaps more profound truth about human potential and industrial capability. That significant breakthroughs can emerge not necessarily from radical invention, but from the courageous willingness to question and rethink long-held assumptions. This narrative remains a powerful testament to the extraordinary achievements that can arise when fundamental beliefs are challenged and new approaches are embraced. The construction of these ships, while undeniably critical to the Allied success during World War II, serves as much as a symbol of what human effort can accomplish as it does a milestone in naval logistics. Their importance was not solely in their utility or sheer number, but rather in what their rapid and mass production revealed about the nature of industrial possibility. It demonstrated that ordinary people, when given proper training, sufficient motivation, and the right organizational system, could accomplish feats once thought reserved for highly specialized craftsmen or industries with centuries of tradition. Before this wartime innovation, producing complex maritime vessels was understood as a meticulous process that took years, often involving generations of craftsmanship and craftsmanship traditions. These ships represented the culmination of accumulated expertise, and their manufacture was considered an art that could not be hurried. Yet, when circumstances demanded rapid expansion, necessity itself becoming the mother of invention, it became clear that these long-held beliefs about manufacturing were not fixed truths. Instead, they were assumptions that could be challenged through systematic ingenuity. Industries that had been resistant to change for centuries suddenly found themselves undergoing a radical transformation within a matter of months, driven by the combined forces of necessity and inventive thinking. The pace of change in wartime was extraordinary, revealing that even the most complex industrial processes could be overhauled if approached with a mindset receptive to questioning the status quo. Reflecting on these achievements, Admiral Chester Nimitz, an esteemed commander of the Pacific Fleet, captured the essence of this industrial transformation in his memoir published in the year 1960. He chronicled how American maritime production stretched across thousands of miles of the vast Pacific Ocean, where ships were built at such a rapid pace that they were being replaced faster than enemy forces could sink them. This relentless production became a crucial element in maintaining the logistical backbone of the Allied war effort on the Pacific Front. Japan's military strategists, observing the relentless output of American ships, had initially believed that American industrial capacity was formidable but finite. They operated under the assumption that sinking a certain number of ships would eventually cripple American logistics, forcing the United States to negotiate or surrender. However, these calculations failed to account for the extraordinary ingenuity of individuals like Henry Kaiser, an industrial leader whose innovations revolutionized shipbuilding processes. By the year 1944, the United States was capable of replacing shipping losses at a rate faster than they could be inflicted by enemy sabotage or attack. This mathematical advantage, based on the daily capacity to build multiple ships, meant that attrition, which traditionally favored the side with greater destructive power, was fundamentally shifted in favor of the side with superior manufacturing capability. What mattered most was not the valor of individual sailors or soldiers but the capacity of American industry to outproduce and outbuild the enemy. The Pacific War, therefore, was ultimately won not only in battlefield confrontations but equally and perhaps even more decisively within the shipyards of Richmond, Portland, and Baltimore. These industrial centers, fueled by innovation and reorganized systems, proved that the outcome of a conflict could hinge on the ability to manufacture at scale and with unprecedented efficiency, just as much as it depended on bravery on the front lines. Keystone to Kaiser's legacy was not merely the impressive number of ships, approximately 1,490, that his yards produced in record time, but the revolutionary transformation in industrial understanding that his methods represented. Among these was the legendary case of the Robert E. Peary, which was assembled in less than 5 days, an astonishing feat that demonstrated traditional manufacturing timelines could be cut dramatically through systematic rethinking. This achievement served as concrete proof that long-standing assumptions, which limited productivity, could be questioned, challenged, and ultimately overturned. Kaiser's innovations did not go unnoticed. In the years following the war, the maritime establishment and the broader industrial community, initially dismissive of Kaiser's outsider status, spent decades studying, adopting, and refining his techniques. What was once considered unconventional quickly became integrated into standard practices, shaping manufacturing processes across a multitude of industries globally. The young workers who acquired skills in welding, fitting, and fabrication during the wartime emergency carried these competencies into peacetime economic recovery. Their skills and newfound confidence became foundational in rebuilding and modernizing America's post-war economy, proving that the lessons learned in times of crisis could be seamlessly adapted to serve long-term industrial growth and innovation. In essence, the remarkable story of how Kaiser's approach enabled the rapid production of Liberty ships in mere days instead of months is more than just a tale of manufacturing efficiency. It is a compelling demonstration of transformation through inspiring demonstration and bold inquiry. It underscores a fundamental truth: the story of the Liberty ships, which was vividly illustrated in the bustling shipyards of Richmond and evidenced by the remarkable achievement of constructing 28 ships within a span of just 2 years, remains profoundly relevant today. This era-defining chapter in industrial history, with a total of 2,710 vessels completed, showcases a principle that continues to resonate across various industries: that challenges deemed insurmountable by conventional wisdom are often only barriers awaiting innovative approaches to be shattered. Although the original fleet of Liberty ships has long since disappeared from the seas, many dismantled decades ago or lying dormant on ocean depths, the revolutionary spirit they embodied persists. It echoes strongly within modern shipbuilding yards, where techniques such as prefabrication are now standard, as well as in countless manufacturing facilities worldwide that prioritize rapid, specialized training over traditional, slow-learning processes. This spirit also lives on in the minds of forward-thinking managers and leaders who question whether impossible truly means impossible, or simply indicates that no one has yet devised a solution. The enduring legacy of Henry Kaiser does not rest in the steel structures he helped create but in the transformed understanding of human potential and collective effort he inspired. His leadership showed that when liberated from orthodox methods and constrained by outdated assumptions, dedicated teams could achieve extraordinary feats. From the moment in December of 1940, when Kaiser signed his first contract with little prior knowledge of shipbuilding, to November of 1942, when the vessel named Robert E. Peary was launched after fewer than 5 days of construction, and culminating in September of 1945, when the very last Liberty ship was delivered, Kaiser's achievements became a testament to what human ingenuity can accomplish. Kaiser demonstrated that industrial revolutions are driven not merely by small, step-by-step improvements, but by radical reimagining of what's possible within the bounds of industry and human effort. The 2,710 Liberty ships built during the years of 1941 through 1945 did not just ferry cargo across vast oceans. They carried proof of a profound truth: That human creativity, when unfettered by tradition and fueled by necessity, has the power to turn the seemingly impossible into reality.